Hello, finally getting around to having a look at this ACA1221 little accelerator memory module unit.
Please excuse the crudity of this model. I didn't have time to build it to scale or to paint it.
Right, we've got a bit of damage here, as you can see. I bought it faulty. The 3V 3 regulator was getting hot and the user tried to take it off. It seems to have melted what looks like a floppy drive connector.
Great Scott!
Anyway, I'm not really bothered about that. So I can't find a schematic online for this.
Great Scott!
As you can see, it's completely come away. A couple of wires there, see that? Yeah, I can see what's going on now. That's actually ripped up. This here is what's left of the IC, the 3V 3 linear voltage regulator. That's a wire there, and there's one there, and that looks like the top of the pad for the wire, and that looks like the other bit. This bit here is what's left of the track that used to come down there, down to there. So this whole piece is pulled across, and it's precariously hanging on the track that leads to that capacitor there.
This is what makes time travel possible. The flux capacitor.
Still attached at the minute. Trying to push it back without breaking it. Easier said than done. Doesn't really matter. But nice to get it back where it was. But I think I found the problem actually. I'm not too sure. There's another capacitor like this one, and it looks to me it's a dead short. But it might not be that. It might be something else. But it's showing a dead short across it. So obviously it shouldn't be. I'm just trying to work out what that leg is. So obviously that's stretched up. It's got to be pulled down. So the best thing I can do is take that off there really. Unsolve that off out the way. Somehow I'm going to attach those wires and maybe glue this back down. So first thing, let's get this leg off what's left of the pad.
Whoa, this is heavy.
Yeah, I haven't been on for a while. I've done no uploads. Been doing some refurbing of quite a few Amigas, some retro brighting and checking capacitors out. Took apart an Amiga 1200 and had a look at it. Broke the seal on it.
Great Scott!
And to my surprise, when I examined it, there's no corrosion, there's no apparent capacitor leakage. All the pads on the capacitors are shiny, so I'm still in two minds whether to recap it or leave it alone. It's in surprising good condition, really.
Hold it, fellas. I'm afraid you're just too darn loud. Next, please.
Anyway, yeah, soldering iron's warmed up now, so let's just remove that little leg. Right, I'm going to put a little bit of flux down on here. Looks like a huge amount, but it's only a tiny bit.
Marty, this may seem a little forward.
I'm now going to take that leg off and leave the pad there, hopefully. Ready? I don't want to come off. Why no? Alright, we got him off. Lovely. Right, he's off. Let's get some nice tweezers. See what we got left here. So we've got a pad that we need to get reattached. How am I going to get those wires attached? You can see the mess they made of it. That capacitor there, I suspect, is being short circuit.
The only power source capable of generating 1.21 gigawatts of electricity is a bolt of lightning.
Right, so we've got a meter up the top. It's a Unity ACA1221. Put it on ohms. And you can see 3 ohms, 2 ohms. It's like a dead short. From what I can gather, there's a capacitor there, the back tab of the regulator, then there should be another capacitor here. There's a one across there. If I remember right, this is the incoming leg. Can't get the schematic. And what that does, it just powers up the ICs for the FPGAs or CPLDs, whatever they are. Powers the voltage up for that, possibly the RAM as well. So we've got V in, V out and ground, that's right, as I thought. That tab there, this space here, will be 3V 3, and so will that one. This is V out, these two. So V in would be this one here, this is V in. And you've got a capacitor there to go into ground.
This is what makes time travel possible. The flux capacitor.
That's a capacitor going to ground. There's your ground. 3V 3, 3V 3, and then a capacitor going across from 3V 3 to ground again. And you've got a capacitor going. There's a short on this between there and there. That's ground probably. And there's a short, and this is 3V 3, and this is getting hot. So if that was short out, this may have blown the track open circuit.
Great Scott!
So let me zoom in on that and see if there is any remnants of the track. See this, what used to be a pad here? Little tiny track going from there to the capacitor down to ground. There's a wire there as well, I've just noticed. That's probably... why is there a wire there? God, it's going to be awkward to get good working. I've got wires everywhere. Another wire there as well. So I reckon that used to be there. Must have been a track going across to this. So that must have blown open circuit because of this. Right, what I'm going to do is take this capacitor off. Now I'm going to try my new gadget. Let's get the voltage up a bit. Right, so yeah, there's more to sticking a regulator on than meets the eye. Get all these wires connected up again. Nasty job. As I stick some wire down. Right, I'm up to temperature according to that. Let's take this off then. Right, we're going to use these hot tweezers.
This sucker's electrical, but I need a nuclear reaction to generate the 1.21 gigawatts of electricity. 1.21 gigawatts!
First time I've really tried these, so... Right, we're just going to put a bit of flux down here onto there. Just to make it a bit easier to work with. Right, here we go then. We're going to take that capacitor off, and I need to measure it when it's off to see if it is short circuit or not. Right, here we go.
What about all that talk about screwing up future events, the space-time continuum?
Well, I figured. What the hell?
It's not doing a good job, is it? The heat needs to go up. Let's give it more heat. That's 400, it says. There's a big ground plane on that though. Basically made the whole thing a big ground plane. Here we go. I'm going to give it another go. No more flux, so... See that? It's not budging. Right, let's go again. Ready? We got him.
It worked! It worked! I finally invented something that works!
Right, he's off. Let's have a look at the mess we made. Not too much. Right, the main thing now I want to test is... I want to see if there's a dead short on that. If there is, I shall be a happy man. If there isn't, then we probably got a scrap thing going on here. Okay, there we go. And we've got no short. Oh, that is not nice. So that's not the problem. So we've still got a dead short somewhere. And where would we have a dead short? Is it a component that's gone? Oh, that's weird. See that? It's like the whole thing's got hot and melted. Can you see the this here? It's only the flux. I thought what's it had lifted up. Right, I'm just going to tidy that up a bit. Let's just tidy that track up a bit there. And that one. We're going to have to restore some 3V 3 to that. And someone's saying, I wish I never started this now. This is not a 5-minute job.
Don't worry! As long as you hit that wire with a connecting hook at precisely 88 miles an hour, the instant the lightning strikes the tower, everything will be fine.
What is all that mess there? What's all that crud? What is that? Let's get some petrol on it. Right, yeah, so we can see 2 wires. It's not cleaned it very good, is it? There's another wire there. Yeah, because you've got ground and then you've got a wire coming through. So that could be a short out for a start. That looks like it's shorted out there. Looks like it's gone and ate its way through. You need to get rid of solder mask really. Yeah. can see. That is ground, and right next to it is the 3V 3. That's a bit of bad design, really. Put the 3V 3 right next to the ground like that.
Damn! I'm late for school!
Let's get rid of some of this stuff.
Can you feel it?
This is your 5V in, and you've got 2 wires there and there. Track goes up to this. So what I've got to do, I propose to put this on a little piece of circuit board. So we've got to get 5V to these. We've got to get 5V to that and that from, well, that looks like it's where it's fed from. 2 middle ones are ground. The top one is 5V probably. I'm not sure what this one will be. Another 5V or 12V. Right. Now that definitely looks like a piece of track there, doesn't it?
This is it. This is the answer.
More Zippo to clean. Do some more cleaning. Okay, so it's a bit clean around there. This here is track 3V, 3V, ground, and ground. Yeah, you can see where the grounds are. You can see the grounds there. This is the relief, heat relief. And you got 3V and via, and then you got a via there. Now these two should be continuity, or is that just a via just to keep this pad attached? And you got 2 vias there. That's broke off altogether then.
What if they say I'm no good? What if they say, get out of here, kid, you got no future? I mean, I just don't think I can take that kind of rejection.
That's broke off altogether. That's okay. That's okay. Get rid of it. You can see where that's got to go. Right. So you know this is ground here. See where this all goes. I don't know if there's a middle area. So now we've tied it up a bit. So you got ground. Don't know where that goes to. So I think I'm gonna have to stop this for a bit and resume it.
Whoa, this is heavy.
There's that word again, heavy. Why are things so heavy in the future? Is there a problem with the Earth's gravitational pull?
Let's clean it up with some Zippo. Put the capacitor back, I suppose I better add. Oh yeah, you can see it's not attached. Alright, let's put the capacitor back. We know the capacitor was okay. Wasn't the capacitor that had a problem. Let's see if we can get this back. Taking it off is one thing. Putting it back on is another. So, let's see if I can get this soldered manually.
Next Saturday night, we're sending you back to the future.
Let's do it with hot air. I've got solder tweezers for taking stuff off. Let's put a bit of flux. That's not working. Yeah, Got the patience to go with this and a steady hand. Not easy. No, it's not happening. Right, leave that. I'll get some solder braid. Right, that's the end of that transmission. Okay.
Hey, Doc, we better back up. We don't have enough road to get up to 88.
Roads? Where we're going, we don't need roads.